Welcome to the Trend Detection Podcast, powered by Siemens.
Hi everyone, I am Liz Maginn. I am a Senseye marketing professional who works with predictive maintenance, and here joining me today is Natalie.
Hi everyone, I'm Natalie Kurgan, and I've been working with Senseye for 3.5 years now, and I am the delivery training lead for Senseye.
And today we will be talking about offline data and why we don't really use it. So jumping in, Natalie, what is offline data?
So offline data is almost a misnomer. Now, sometimes a prospective customer or a customer might want to send us loads or even just months of data that they've collected on machines in the past, and they want us to analyze it. And that's true offline data. The other flip side is that they want to take that historic data, that old historic data, and push it into the app. So it almost seems like it's online because it's in the app, but it is still past data. So those are the two types of things we refer to when we refer to offline data.
And what is that? Why do customers want to do that?
I think, I don't know what messages are going around in the PDM space. I know PDM is like a big buzzword and a lot of people are using it, but I think people are using it to describe things that aren't actually predictive, or they're being used to describe analysis techniques that are traditional data science techniques. So that's what a lot of people think of when they hear that we use AI and machine learning to learn what your machine's normal behavior and to alert you when something is out of normal. When they hear that, they automatically think, oh, you have to train the models. You need loads of historical data. We want you to prove that your models work. And we say, no, there's no models in that sense. So there's nothing to train. It takes 2 days for the system to learn what your normal baseline is once you get data into Senseye, and then it just goes. So it's usually they want the app to prove itself. They want it to make sure it works on their data. But the thing is, the app does not care about assets. It doesn't even care about what data you have. It just assumes you're giving it a condition indicator. If you give the app a condition indicator, it works. There's nothing to prove. So that's usually what folks are trying to do. They're trying to fit us into a data science box that we really just don't fit in.
So for example, when we're pulling that data, you say that the assets don't matter. Can you explain a little bit more into that?
Yeah, so within the app, you can define asset types, and that's really great for users to understand what they're looking at and know where their point of maintenance is. However, the app doesn't really make differentiation in between assets. It can if you put them in fleets. That's a different conversation. It doesn't automatically know what to look for if you say this is a motor, because we're not telling you that you have to provide a certain amount of data and certain different types of data for a motor. We take what you have and we do our best to make it work. So to that end, the app is asset agnostic. It doesn't know what assets you're putting in. You can name them and stuff, but the algorithms don't know and they don't care. All they care is you're providing it a measure that is directly related to the health or state of the machine.
So kind of you put in those parameters from top to bottom, and that's how we, as in the product, works.
Right.
Awesome.
So it's just that the algorithms work on one simple assumption, and that is that you as a user are providing condition indicator data. That's it. If you do that, the algorithms work.
That's awesome. It sounds pretty useful when we're looking at those kind of large companies that have tons of different types of assets.
Yeah, I think so. We don't create like a set of parameters like, oh, if you want to onboard a motor, you must have this. No, provide what you can, but have realistic expectations. If you're looking at a fleet of motors and all you have on each one is motor current, we can monitor it. We can look for certain failure modes, but we are not going to catch all of them with just motor current, just as no one would be able to catch all of them with just motor current.
That makes sense. How does offline data affect the data quality?
How do you mean?
So, for example, you said that we can't push, we don't want to push in their historic data, obviously, which is their offline data. But when they do, customers force you to do that, or
Sometimes, yes. And when they do that, they're really taking away a huge functionality out of the application, because a huge part of the app is the user using it and feeding back, and the system learning from the user and the user learning from the system. When you're feeding in historic data and just expecting the algorithms to just go, you lose all of that. And working with Senseye is really a cyclical process. Like I said, the app learns from you and you learn from it, and you feed back to each other and improve things constantly. So if you expect to just throw in whatever data you have and expect to get amazing results right away, that's just not how it works. And I don't think that's how you want it to work. The models that they're trying to compare us to in that sense tend to be really rigid. They tend to not be very scalable. And they're not AI machine learning. So why do you try to fit us in that box? It's not how we work. It's okay in some instances to send us historic data, but not for the purposes of testing whether Senseye works. If there was like a failure that you saw in the data and you want to see it in the app, and we want to try, failure matching, great, send it. That's great. But to actually just test whether the app works, just send us live data, and then you might get real true value, real downtime avoided, or whatever KPIs you're looking for, real time.
Yeah. Do you run into problems with people wanting to send you the live data?
What, the live data?
Yeah.
No, we love live data.
No, I know, but do you run into problems with customers saying oh, we don't really want to send you our live data? Like that's too...
Well, I think they would love to send us live data, but I think they really get caught up on two things. One is this just idea that they have stuck in their heads of this data science model, and that's not what we are. And so they really have it stuck in their heads that, no, we need to provide this. You need to prove it works. Like, no, it doesn't work like that. But the other thing is that integration is scary. It's big, it's tough, but we do have simple, straightforward ways. I hesitate to use the word simple and straightforward when we talk about data integration, but it really is as basic as dropping a file in an S3 bucket once a day.
What are some common arguments that you get from customers when trying to explain to them the value of using the live data versus the offline data?
So a lot of the time when we encounter this, it's because we are sort of in a pool of vendors that they're testing out, and they're testing everybody the same way. And so when we try to come back with that's really not how it works, they say, but we're testing everybody this way. We need to put everybody within these same constraints. And it's like apples and oranges. It's like, okay, you're testing two completely different things in one way that is really geared towards one of those two things. And does not take advantage of the full capability of Senseye. So it's tough. If it was an easy conversation and easy to change their minds, we wouldn't be having this conversation right now. It happens a lot.
Yeah. Can you explain a little bit more on how we differ from the data science models?
Sure. So data science models, and I don't mean to disparage them, they definitely work well in a set of circumstances, but typically they're made by hand per asset type, or not even per type, sometimes per asset. And it can take a huge amount of effort to sort of manually create these models. And then they're rigid. They're not, I don't know if they have AI built in, but they're typically not going to be learning as time goes on. And then they're certainly not scalable. And that's Senseye's calling card, is we're scalable. And I've said it time and again to different customers. It's like, if you're going to onboard 100 assets and you've got 15 different asset types, I would almost rather you onboard like 3 asset types and give me 1,000, because it's as easy to onboard one motor into Senseye as it is to onboard 100 or 500. I don't care. It's the same thing as far as configuration goes, as far as the algorithms go. And it's even better for the algorithms to have that to compare it against, so that you can set them up in fleets and they can look at the group as a whole. Anyway, that's the whole point of Senseye, to get things in bulk, and you're not building individual models. The AI and machine learning does it for you. And folks have a hard time wrapping their heads around that. It's complicated. But we are not sitting here. I'm not sitting here building individual models and creating all this pages and pages and pages of code in the back end to process your data. We're not doing that. All we're doing is sending condition indicators. And that might involve filtering your data. It might involve, creating some complex condition rules to say, if this measure goes up and this one goes down, tell me about it. That, things like that. But there is no creation of a data science model when you onboard into Senseye.
I agree. Like, I understand why it would be hard for someone to wrap their head around, because I struggle with the whole AI and machine learning thing on its own. Could you explain just a little bit on how that works?
So the AI machine learning is, well, let's talk about it in not using technical terms. Basically, it's going to take in your data, and right when your machine comes in, it's going to assume that the first 2 days your machine is in, it's going to assume that the machine is in normal operating conditions, normal condition, normal health, not in a state of degradation, which might be wrong, but we'll figure out how to address that later. So it establishes what normal is, and it kind of uses that moving forward to see, hey, these new data points come in. How do they compare against what we saw in the last 2 days? Do they fall outside of the kind of standard deviation? Are they drifting up? Are they spiking? Are they stepping? What are they doing? If they're doing something totally outside of normal, the app will potentially tell you about it if it's severe enough, basically. It's not going to tell you every time any little thing happens, only when it's significant. If you do onboard a machine that's already in a state of degradation, if that degradation gets worse, it will tell you about it. If you have a fleet of assets, and I always advocate for this, the first thing you do, get 10 motors in, look at them all together, and you'll see which ones are offset from the group. And then if any of them are onboarded, already unhealthy.
Oh, that's a super easy way to understand it, because that's something that I've always kind of struggled with, is like how to wrap my mind around that kind of thing.
Does it make sense?
Yeah, it does. It makes so much more sense than a lot of it. How would you describe the limitations of offline data to our customers when using Senseye Predictive Maintenance?
So I've used this analogy before, and I've told our sales folks that it might help, is that if you want to judge how Senseye works just by using offline data, that is like judging how well a car might work by rolling a tire down the road. You're testing the absolute most basic functionality, and you're not providing the feedback that Senseye thrives off of, and that is how it learns and improves. So taking that away, you're really not getting an accurate assessment, because part of Senseye's success is users have to use it. And if you provide historic data, and all the cases are in the past, and they're things that have already happened, no one's going to be using it. You're just looking at it retroactively, not maybe seeing the benefit of it. So live data is always the way to go.
Do you want to talk about data quality and how that kind of affects a lot of what we do?
Yeah, sure. So first, let me take a step back. A lot of times when we get told that we are going to do like a proof of concept with offline historic data, we always groan, because we're usually 9 times out of 10, we are just thrown a whole bunch of terrible data, and we're told, here, make something happen with this. That's not how our process works. So when you're doing offline historic data in this way, you're also totally disregarding our proven process, which is actually in the Help Center. It's called Senseye Knowledge Platform. It's many steps that we follow that we've proven time and time again with our customers. And that's how we get quality data for each asset type that we onboard. So when we're throwing a bunch of old historic data offline, the customer doesn't even work with us to understand, what are these assets? How do they work? How do they fail? What are these data? What are these measurements you've sent us? How do they relate to the health of the machine? These are the questions that we ask that we're often not able to ask when we have to do these sort of analyses. So data quality is often a big issue when we do this offline analysis, because we finally, they sent us a whole bunch of data. We throw it into the app and we find, I don't know, maybe we're only receiving one data point every 4 hours for something. That's not going to work. And they would have known that if we'd followed our process. We might find that actually the sensors aren't placed in a good spot at all if they're monitoring vibration and the vibration is erratic and useless. Like, they might not know that, but again, if we'd gone through our process, we would have gotten through that together. So it's not just data quality, but it's ignoring our whole process for onboarding and configuration.
Yeah. Do you want to go in a little bit more on that process of onboarding and our, integration?
Sure. Yeah, so we follow a process that starts off, usually someone like me will talk to a new customer and say, okay, what asset types do you have? Do those types actually agree with what we would consider in Senseye to be an asset type? We start there. If they're not, we might drill down a little deeper and figure out, okay, well, what you're calling a fan is actually a motor, a gearbox, and an impeller, a fan. It's actually 3 assets, not 1. And you actually do have data for all 3 components independently. So let's monitor those 3 separately. That would be step number 1. What are your assets? Step 2 is to figure out, okay, what issues do you see with these? What are your top maintenance events? Like, what are you trying to achieve by monitoring these assets in Senseye? From there, we figure out what data do you have available, and we might even get into discussions about process data, airflows. That might have an effect on how your fan is working. And these aren't necessarily givens. Like, there's no set recipe for how do I monitor a fan. It depends on the application. It depends on what the customer wants to see. So it's really customized, this process of working with the customer to figure out how best to onboard their data into the app. You might think this is not scalable. It is, trust me. The first couple asset types we work through, I say asset type and not assets. If we work through one fan and we get it figured out and they have 100 of those, we've done it once, that's enough, get them all in. But usually once we've gone through it a couple times, they don't need our help anymore. They understand now, they've seen some cases in Senseye, they kind of get it, and now they can do them on their own. So that's just figuring out what data to get in. We also have to figure out, do we need to remove the off states? Do we need to isolate states in the data to provide a single state condition indicator? There's a lot of things to consider, and we don't go through this when we end up having to do offline analysis. And there's a huge component in the success of Senseye that has to do with the education of the customer in data and analysis and PDM. And so that's the other part that we neglect with offline analysis.
Yeah. So I know we talked at the beginning kind of a little bit about what predictive maintenance is and kind of like what it is not. Could we go into that in a little bit more detail? Because I know we're not, data scientists. We're not really going through that whole algorithm, but like, can we describe a little bit more of like what we're doing?
Yeah, sure. So for one thing, predictive maintenance is not an app. It is not me. It is a strategy. And it isn't all or nothing. You're going to be doing reactive maintenance on light bulbs. If a light bulb goes out, there's no sense in monitoring it. Just replace it. It's just as much work, probably more costly to monitor the thing. So predictive maintenance doesn't mean you're going to put everything into the app. It doesn't make sense. As well as I compare PDM in a much more relatable sense to weight loss. I think everybody can relate to this at some point or other. If you want to achieve weight loss, do you just download an app, throw a bunch of information in, and then expect to lose weight? No, there are other things involved. You have to maybe you need an exercise app to help know when to exercise, but then you have to do the exercises. Maybe you have a dieting app that helps you, find recipes or whatever, but then you have to do it. So Senseye to PDM is just a tool in your toolbox. You have to engage with it. You have to use it, but you have other tools too. It's not going to replace your CMMS. It's not going to replace other tools that you might be using. So I think that's something that people have gotten confused with. Again, I don't know what messaging is going on out there, but anyone that tells you that their app is PDM and it is the total solution, it's just a tool. Senseye is just a tool, and it's not going to replace anyone. Somebody still needs to use it, engage with it, feedback, and really make it a central part of their practice. Now, the actual point of PDM is not to predict when your machine is going to fail. It's predicting when you need to maintain your machine. And those are not the same thing. So it really depends on your maintenance strategy. How much of a window do you want to have before you need to maintain your machine? When do you want to be told, basically? So what I usually work through with my customers when I'm working one-on-one, and we do case reviews. So we review the information Senseye gives them and find out if it's been helpful, if it's not been so helpful, and if not, what do we do about it? Basically, all I'm trying to get out of them is, what do you want Senseye to tell you? And if we can get that out of a person, we can make it happen. But that is a lot harder to get out of people than you realize, because they don't know what they want to see. They've just been handed this app and said, here, you need to use this. So I think in order to adopt a full predictive maintenance strategy, you need to train your reliability engineers. You need a full hierarchy of, you need a structure of support. If you get a case in the app, what are you going to do about it? What if there's something going on with the machine? Who reports to you, and who do you report to? So it's a lot more than just an app. Does that even answer your question?
I don't remember what my question was, but that was really interesting, and it made like a lot of really good points. I think it's very good for us to emphasize that we're not replacing anyone. We're just helping. We're just going to provide that benefit. And I love that you use analogies. Like that helps so much, especially in my marketing brain, as I'm not an engineer.
Yeah, I think that's fine. And I think we get caught up, like, Senseye is a great product. It works really well, but it is not predictive maintenance. It is a tool to help you achieve predictive maintenance, but you still have to do the work as a user of it. And that's something that gets a little bit lost in translation. People get disappointed. Oh, why is it telling me this? It's like, well, it's telling you that because something's changing with your machine. If you're not interested, you need to feedback and, hone it in. But it's a process for sure.
Yeah. And it like just points the maintenance on where to go look to make sure it's not breaking. It's kind of like a check engine light, but a little bit more specific. It's like that one that you plug into your car that tells you like the errors, and then you have to figure out what that means.
Yeah, exactly. Well, when you first get started with Senseye, it's a huge learning curve for the user to start look. Sometimes people have never seen their machine's data before. So sometimes that's what we're starting from, and that's fine. But what it sometimes starts off as, okay, Senseye has said something has changed on this asset. These measures have changed, but I don't know what that means for the actual health of the machine. Somebody go investigate it, find out what that means. The critical part is when somebody's investigated and figured it out, they need to come back and tell us, tell the app what happened, so that next time the app can give you more pinpointed evidence or information on, here, your asset has changed. Here might be possible things that you should go investigate. So that's really what we're working towards, is getting that expert knowledge into the system.
That's really interesting that it could then picks up on like what happened in the past and can be like, oh, it's probably because something's loose, or,
Yeah.
The weather's weird.
Especially with this Copilot now, because it can read everything you've ever told the app, every note you've ever put in, every work event, every case closure comment. So it's really important that you provide the app with good detail in what you're investigating and what you found.
Yeah, the Copilot, just to clarify for everyone, is our new AI that's integrated into it. That's kind of like a Chat GPT, but not. It's closed. It's more specific to your machine and your information, and then it'll talk to you in the moment.
And when we say AI, just to clarify, that is not the algorithms. The algorithms are their own AI. They're their own genius. Honestly, they are the selling point of Senseye. The Copilot is like generative AI.
Yeah, it's like going to ask someone else for advice, and instead you can just ask the app, which is a nice little feature that we throw in there. Is there anything else that you would like to let people know about data, offline data, or Senseye in general?
Can I pause? Can I ask you a question?
Yeah.
Is this geared towards Siemens, or is this external, or
This
both?
is external.
Okay.
Just made it more complicated. I'm sorry.
Yeah, I don't know. I think we've pretty much covered everything.
Yeah.
I guess just the main point is that you can't stuff Senseye into a traditional data science box and expect it to perform optimally. That's not what we do. So please listen to the Senseye experts when we're telling you, here's an alternative and you will get much better results. and much more accurate testing. If you're wanting to prove the app works to your organization, send us live data. That's it.
Yeah, might as well trial run the real thing versus
And go through our full process. Even if it's just 3 asset types or 1 asset type, 10 assets. Go through our process, see what it's like. You're probably going to learn something new.
Well, I certainly have learned a lot today. So thank you so much for joining. I really appreciate it. And I hope everyone enjoyed your knowledge. It's great talking to experts.
Thanks, Liz.
Thank you.
Please like and subscribe on all major podcast channels and find out more about Senseye Predictive Maintenance at Siemens.com.